multiplying and dividing radical expressions. So here we have the cube root of 3 times the cube root of 54. Well, that could be rewritten as the cube root of 3 times 54, all under one radical because they're both the cube root. If we're trying to see what we can multiply and what we can bring out, let's see if we can break down 54. Well, 54, I have a 3 already, so let's start with 3 and see what we can do. 54 is 3 times 18. Now I have two 3's. I have a cube root here, so let's see if we can get a third. 18 is 6 times 3. I'm not going to be able to get any more groupings out of the 3. I could break that down into a 3 and a 2 for the 6, but it won't help me out because I don't have any more sets of 3 to pull out. So we could think of this as the cube root of 3 to the third times 6. If I have the cube root of 3 to the third, well, 3 divided by 3 is 1, which means I can pull out a 3, and I have the cube root of 6 left over. Let's try again. So we have the fourth root of 3x to the 9th, y to the 12th, times the fourth root of 54, x to the 4th, y to the 7th. So that means that we have the fourth root of 3 times 54 times x to the 9 plus 4 gives us 13. Y to the 12 plus 7 gives us 19. Well, 54 we just got done breaking down in the last one, and we saw that we could do 3 times 18 and then 3 times 6, and 6 we could make 3 times 2. So we could rewrite this as the fourth root of 3 to the 1, 2, 3, 4 times 2 times x to the 13th, y to the 19th. 4 divided by 4 is 1, which means I can pull 3 to the first out. 2 I can't really do anything with, so we only have 2 to the first power, and it stays underneath the radical. X to the 13th, well, 13 divided by 4 is 3, with a remainder of 1. Y to the 19th, 19 divided by 4 is 4, with a remainder of 3. So that's going to look like 3x to the third, y to the 4th, times the fourth root of 2xy to the third. Let's try another one. Let's look at the cube root of a plus 5 times the cube root of a to the second minus 6. Well, now I don't have just the same radical on each side. So instead of just combining it all under one, I need a FOIL so that I can get all these pieces together. See the separation right here with the addition and the separation right here with the subtraction. So if I FOIL these together, that means we're going to have the cube root of a times the cube root of a to the second, which is going to give us the cube root of a to the third. The cube root of a times negative 6, which is negative 6 times the cube root of a. 5 times the cube root of a squared, which is plus 5 times the cube root of a squared. And then 5 times negative 6 is negative 30. Now we need to see if we have anything that's the same. Well, here I have a to the third, here I have just a, here I have a to the second, so I don't have any common pieces, so this is going to be finished like that. Let's look at what we do if we have the square root in a denominator. So something like this. Well, we don't want to leave the square root in a denominator. Sometimes you have it like this, where you have multiple terms. Sometimes you have it like this, where you have just one term. But in either case, you want to get rid of that square root in the denominator. If it is something like this where there's just one term, you need to get rid of the square root. Well, if I multiply by the square root of 6 over the square root of 6, then that would give me in the denominator the square root of 6 squared. 6 squared I can take care of. I can't take care of just the square root of 6, but I know the square root of 6 squared is 6. So this gives me the square root of 6 in the numerator over 6. That's called rationalizing the denominator. It's getting the radical out of the denominator. But here, if I used that same idea and just multiplied by the square root of 7, when I distribute that square root of 7, it would get stuck with the 5. So that's not going to help us out. Instead, I need to do something called the conjugate. And the conjugate means you look at what you have in the bottom. So in this case, we have 5 minus the square root of 7, and you switch the sign, but then you multiply top and bottom by that same thing. So the conjugate of 5 minus the square root of 7 would be 5 plus the square root of 7. So if we multiply by that, in the numerator we're going to need to distribute our 3. So that's going to give us 3 times 5 is 15, plus 3 times the square root of 7 is 3 root 7. But watch what happens when we FOIL in the denominator. 5 times 5 is 25. Then we'll have plus 5 root 7 minus 5 root 7. And then the square root of 7 times the square root of 7 would be the square root of 7 squared, which is the square root of 49, which is 7. So then we have our negative times our positive, so that stays negative. And then look right here. Now we have eliminated our square root in the denominator. Yes, we made a square root in the numerator, and yes, the numerator looks a whole lot worse than it did, but we don't have a square root in the denominator, so now we have rationalized. 25 minus 7 gives us 18, and that would be our simplified format. Let's try a conjugate again. So we need to multiply by the conjugate. Well, the conjugate means that you take what you have in the denominator and you switch the sign. So in this case, a plus 3. So if we distribute our 4 root 5 times the root a, we'll get 4 times the square root of 5a. And then 4 root 5 times 3 gives us 12 root 5. All over in the denominator, the square root of a times the square root of a, that's just a, plus 3 root a minus 3 root a, so those cancel. Negative 3 times positive 3, that's negative 9. What happens if instead of a square root, you have a cube root? So maybe we have 2 over the cube root of a. Well, right now I have a to the first power. I don't want a to the first power. I need a to the third power in order to get rid of this one. So that means in order to get a to the third power, I need to multiply with an a to the second under the cube root. If I do that in the denominator, I will get the cube root of a to the third. See what we did? I needed 3 under the radical, so that the cube root and the third would leave me with just a. I only have 1, so I had to multiply by a to the second. And in the numerator, we get 2 times the cube root of a to the second. So this is going to give us 2 times the cube root of a to the second in the numerator, all over just a in the denominator.